Welcome to Two Projects. In this video, we are going to explain the project Effective Management of Blockchain-based Agri-Food Supply Chains. Introduction. The aim of this project is to revolutionize the Agri-Food Supply Chain Management by introducing the concept of DRSCM, that is Deep Reinforcement Learning-based Supply Chain Management. In traditional supply chains, customers often can't easily tell if the products they want to buy are really good quality. Meanwhile, farmers often face difficulties in planning and managing their crop production effectively, which can impact how much profit they make. To address these issues, the project utilizes two cutting-edge technologies. First, it employs blockchain to secure data integrity through decentralized storage and cryptographic hashing. Blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And the second technology, DRL, that is Deep Reinforcement Learning, emulates human decision-making processes. In the context of this project, it informs farmers when to initiate production or sales based on the current stock data, ultimately optimizing their profitability. Objective of the project. So, as I mentioned earlier, our primary objective is to implement the DRSCM system, that is Deep Learning Based Supply Chain Management, an approach that aims to revolutionize the efficiency and transparency of agri-food supply chains. And our project seeks to equip farmers with sophisticated tools for managing productions efficiently. By leveraging data-driven insights, we aim to empower farmers to maximize their profits while minimizing waste in their agricultural processes. And we aim to utilize blockchain technology to revolutionize the security and accessibility of supply chain data. Our objective is to securely store and decentralize this data effectively by preventing unauthorized alterations and enhancing overall security. And we are developing a deep reinforcement learning system tailored to predict stock quantities accurately. Our focus is on providing farmers with data-driven insights to make informed decisions regarding when to produce and sell their agricultural products. Requirements needed to execute this project are hardware requirements, processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute this project, we have designed few modules. The first module is input. In this module, users including seed providers, farmers, processors, distributors, retailers, and consumers input crucial product details such as product ID, product name, description, and user type. This information is vital for supply chain tracking. The second module is save ASC details in blockchain. This module stores product information securely in the blockchain. Each product detail is recorded as a transaction block with a unique hash code, ensuring data integrity and enhancing transparency and security. The third module is get ASC details from blockchain. Users access product information stored in the blockchain by providing product ID. This enhances transparency and enables stakeholders to verify product data. The fourth module is deep reinforcement learning simulation. Reinforcement learning, that is DRL, predicts optimal stock quantities for production and sales. The DRL algorithm evaluates current stock as a state and decides whether to produce or sell. Q-learning enhances decision making within DRL. The next module is extension asynchronous multi-agent simulation. This module introduces asynchronous multi-agent reinforcement learning. Multiple agents, each with its environment, learn and share knowledge asynchronously. A global network oversees them, fostering collective optimization similar to human knowledge exchange. The next module is rewards graph. The rewards graph displays rewards earned by the DRL algorithm. Correct predictions result in rewards while incorrect ones may lead to penalties. It offers insights into algorithm performance, aiding in refinement. And the last module is Get All Blockchain Products ID. So here, users retrieve a list of product IDs and they block hash codes from the blockchain, enhancing accessibility and transparency within the supply chain. And these modules together constitute the DRSEM system, integrating blockchain, deep reinforcement learning, and multi-agent learning. They enhance transparency, security, and decision making in agri-food supply chains. Blockchain integration. Blockchain technology is employed to securely store product information within the agri-food supply chain. This means that all relevant details about agricultural products, including product ID, product name, description, and more, are recorded as transactions on the blockchain. And data on the blockchain is not stored on a single centralized server. Instead, it is distributed across multiple nodes or computers that form the blockchain network. This decentralization eliminates the need for central control and reduces the risk of tampering or manipulation. Each node in the network maintains a copy of the blockchain, ensuring redundancy and security. And to confirm the authenticity and integrity of the data stored on the blockchain, cryptographic hash codes are generated using SHA-256 algorithm, that is secure hash algorithm 256-bit, for each block of transaction data. These hash codes serve as unique digital fingerprints for the data contained within a block. Any alteration to the data in a block would result in a completely different hash code. By comparing hash codes, the system can easily detect if any data has been tampered with. And the blockchain system employs a proof of work mechanism to validate and secure transactions before they are added to the blockchain. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is dataset folder in which I have this dataset on which we will train the DRL models. This is model folder in which I have few files which will be loaded into the application later. These are Python main code files and this is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Now double click on it. This graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. So now fill in all these details, the product details, product ID, product name, description, and select the user type from the drop down. So the product ID would be 4. Give the product name, I'm giving it as maize. Give the description, I'm giving it as from Telangana. Now select the user type, I'm giving it as providers. Now click on Save ASC Details in Blockchain button. So we can see the product details are being added to the blockchain and we can see the block number in which the details have been saved and we can see the previous hash and the current hash associated with the block. Now click on Deep Reinforcement Learning Simulation button. So in this graph, on x-axis I have number of days and on y-axis I have stock quantity. And we can see DRSEM stock predictions where green line represents available stock and blue line represents sold stock. And by seeing this graph, farmer will go for stock manufacturing. Now close this graph and in the text area we can see the DRL has given predictions for when to start producing stock and sales stock. So here in the first 3 days we can see the DRL has predicted to start producing stock and in the 4th day we can see it has told us to sell the stock. Similarly, we can scroll down the text area to see the predictions for all the days. Now click on Extension Asynchronous Multi-Agent Simulation button. So in the text area, we can see the rewards earned by the extension asynchronous multi-agent simulation algorithm. Now click on rewards graph button. So in this graph, on x-axis I have iterations or episodes, and on y-axis I have total rewards earned by these algorithms. Close this graph and now click on get all blockchain product IDs. So in the text area, we can see names of each product ID and its block hash code. Now give any product ID, I'm giving it as 4, and now click on get ASC details from blockchain button. So we can see the product details of product ID 4, the product name, description, user type, and these details have been retrieved from the blockchain. So the conclusion here is the project effectively harnessed the power of blockchain technology to elevate transparency and uphold data integrity within agri-food supply chains. This guarantees that customers have access to precise and trustworthy product information. And by seamlessly integrating deep reinforcement learning, the system provided farmers with valuable data-driven insights, equipping them to make well-informed decisions concerning production and sales. Blockchain's decentralized data storage and robust cryptographic verification mechanisms guarantee the security and authenticity of data within the supply chain. And the utilization of blockchain technology ensures unassailable data management, thereby preserving the integrity of pivotal supply chain information. And this project presents a secure, accessible, and adaptable solution for the management of agri-food supply chains, and it not only addresses current challenges but also lays the groundwork for forthcoming advancements in the field.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.